Hey everyone, thank you so much for joining in and welcome to Edureka webinars. So team, in today's session, we'll be seeing how to work with PyTorch library, which is a go-to library when it comes to deep learning. So we'll see about the PyTorch, how to work and all those things in detail. So it's a combination of theory as well as practical. So at the end of today's session, you will be learning some of the key things about deep learning and how to create the same using the PyTorch library. Let's get started with today's agenda. See, as part of today's agenda, we'll be learning how to implement the deep learning neural networks using PyTorch. So as we progress, we'll see what exactly is this deep learning and what are neural networks. The various libraries that we have got in Python for creation of neural network. Then we will understand what is PyTorch and the use cases of PyTorch. And at the end, I'll also share you some of the quick tips as how you can get started with PyTorch library and how to create the neural networks. So that's the agenda for today's session. And when I talk about this deep learning certification training with TensorFlow, this follows a called as structured learning approach. When I say structured learning, it's a special learning approach which has been designed by industry experts to ensure that as a learner, you're going to excel in your overall learning journey and you will take a step-by-step learning approach. Now with the structured learning approach, so you will be starting your learning journey by having yourself introduced to the concept of deep learning and how to get, and then you'll proceed ahead. You'll get started with TensorFlow, which is followed by the convolutional neural network. The fourth module is about regional CNN, that is also known as RCNN, which comes under the object detection. And module 5 is about the Boltzmann machine. And module 6 is generative adversarial network. And module 7 is emotion and gender detection. And module 8 is about the RNN and GRU, introduction to RNN and GRU. And module 9 is about the LSTM. And module 10 is about how to perform the auto image captioning using CNN and LSTM. So as you can clearly see, everything that is required for a practitioner to master this deep learning concept is covered in a structured manner with the relevant hands-on. So by the end of the learning journey, you'll be someone who is ready to implement the deep learning neural networks on the problem domains of your interest. So that's the best part about this deep learning certification training course by Edureka. Now coming back to our learning journey. So as part of today's session, so let's first understand what exactly is this deep learning and how is it different from the learning approaches that we are aware of. See, in the current days, the deep learning has actually changed the world and it changed the way that we interact with the outside. So we are seeing the applications of deep learning in virtual assistants. We are seeing the applications of deep learning in face recognition, recommendation system, email spam filtering. So these are the various places where we see the applications of deep learning. And it has shown a tremendous progress, and the accuracy is like a top class accuracy that we are able to see in all these kinds of tasks. Now, if I want to describe this deep learning, so this deep learning is a subset of machine learning, and this machine learning is a subset of AI, which is the artificial intelligence. So when I say AI, it's a artificial intelligence is an engineering that makes intelligent machines, which is capable of analyzing the data and taking the actions on its own. So that's the role of an AI system. And when I say machine learning, it's a subset of AI. So here, this machine learning system has the ability to learn from the data without being explicitly saying, hey, learn this from the data. That's the beauty of machine learning. Now, when I say deep learning, so deep learning is a subset of machine learning. Now, instead of using the statistical based models here, we'll be using the deep learning neural networks to find the pattern in the data set. Okay, so that's how we describe the deep learning, which is a subset of machine learning. So now that you are aware as what exactly is this deep learning, here I have described that we make use of deep learning neural networks to find the patterns in a data set. So let's understand what is this neural network and how it actually works. So this neural network, okay, this neural network that is also known as artificial neural network is actually inspired by the human brain. So we've got neurons, okay? So we've got neurons at a very high level. We've got neurons, and this neuron has the ability to learn from the data. Now, if I want to explain you in terms of the biological neurons, see, this is what we call it as a biological neuron that you see here on the screen. So biological neuron consists of axon. It has got a cell body, it has got a nucleus, and it also got a synapse. So here, this dendrites is going to receive the data from the other, it's going to receive the data from the other connections. Okay, it's going to receive the data from the other cells. Okay, so it could be from the other cell, it will receive the data, and once it receives the data, it will be processed with the help of nucleus. Okay, so it will be processed in the form with the help of nucleus, and then okay, the data that gets processed in our human brain, it moves through the axon and reaches through the synapses. So inspired by this question, okay, so inspired by this human being's brain working, so the researchers have created the deep learning neural network. So when I say deep learning neural network, this is the common structure which we generally use it to describe our deep learning neural network. So in the deep learning neural network, just like we have got just like we have got the dendrites which receives the input, we have got the input layer through which this neural network is going to get the input, and then just like the nucleus will have, which will help us to process the data, we'll have the hidden layers. Okay, just like I can have multiple cells, he'll have multiple hidden layers over here. Each layer will have multiple cells, and at the end, just like we have got the axon terminal and synapse, we have the output layer. So this is how a deep learning neural network would look like. So we'll be using these patterns in order to find we'll be using these neurons in order to find the patterns in the given data set. Okay, that's the high level idea about this neural network. Now, when we are working with this neural network, we'll come across the various types of neural network. So one general type, or one oldest type, is called as a perceptron. So in case of perceptron, this perceptron is the simplest and the oldest model of neuron which we are aware of it. So this is how the perceptron would look like. Let's say I'll have two inputs, and these two inputs will be sent as an input for my activation function. Okay, so perceptron is a single cell which has got an activation function to represent the perceptron, and at the end we are going to get the process data which will be my output. So that's the role of a perceptron. Here, this is a simple classifier which has been built by the researchers. Okay, so apart from this perceptron, so increasing the complexity, we've got the another kind of network structure that's called as feed-forward neural network. So in the scenario of this feed-forward neural network, we've got all the nodes which are fully connected. And this is used where the data is neither sequential or non-time dependent. So in such scenarios, we'll be making use of this feed-forward layer. So I'll be sending multiple inputs, and this data will pass through in a forward way, that is from my initial input layer to my hidden layer followed by the output layer. Hence we call it as a feed forward neural network layer. And this one, that is the one that is in the middle, that is called as a hidden layer. Okay, so that's the overall idea about this feed forward neural network. Now, once the data passes through the layers, okay, it's going to generate an output. Now, this output that is generated has to be fine-tuned. Okay, this this output like this is what we'll be doing the fine tuning. So in order to do the fine tuning, we'll be making use of a technique that's called as a back propagation technique. Now let's say this is a model that I've created, and for all the inputs that I've given, so the model says that, hey, all these images belongs to the car, but it's clearly evident that, so this is not a car. That is this below example, that is this this is actually a truck, and this is interpreting this truck as the car, which is obviously a wrong. So in order to do the training and fine tuning, we make use of back propagation technique. So this back propagation is a training algorithm which will help us to fine tune my neural network. It will help the neural network to learn from the pattern in a much better way. So the goal for this the goal for this back propagation is to reduce the value of loss or reduce the value of error. First, I'll perform the forward propagation. And once I perform the forward propagation, there I'll be finding the value of loss. And from that value of loss, I'll make use of this back propagation technique so that my goal is to reduce the value of loss in the next iteration. So I'll perform the feed forward. That means I'll perform the forward pass. Then I'll calculate the error. Then we'll perform the forward backward propagation, and this cycle continues. So this is the overall working of this back propagation. Now to implement this entire cycle, that is forward pass and the backward pass, we've got various programming languages. So we've got Python programming language, we've got Lisp, we've got Prolog, we've got R, we've got Java, and we also have the famous and the favorite one, that is Python programming language. So if we are working with the Python programming language, so we definitely come across, and we've got a lot of options when it comes to create these neural networks. So to describe those library names, we've got Theano as a library, we've got PyTorch, we've got TensorFlow, we've got Keras. So these are the various libraries that we have got. And apart from this, there are other libraries as well. There is something called as MXNet, and there are various libraries that we have got. Okay, so these are the top libraries. So out of these top libraries, so TensorFlow and the PyTorch are most used ones. So out of this, PyTorch is very popular, especially in the research space. So here, in case of PyTorch, okay, so in case of PyTorch, this is actually the one which uses a Python based scientific computing. So the code that we write is completely Pythonic in nature. So if I want to construct a network, I'll be constructing it with the help of the Python classes. And the research is being done by Facebook researchers, and it is actively used in this domain or in this Facebook as well. And the best part is this has got the predefined easy to use APIs. And there's a new version that's coming up, that's for PyTorch, that is the version 3, which we are expecting some more new features to be added as well. And this also has the ability of dynamic computation graph. And here it supports fast and it feels native, and it also supports for CUDA. So these are the main advantages of working with PyTorch. Now, before we get started with PyTorch, let's have a look into its origin, how it exactly started. See, this PyTorch, you can think of it as a cousin of Lua-based Torch framework. There was a famous framework which was based on Lua. So based on that, it has been created. Okay, and this PyTorch, okay, it's not simply a set of wrappers to support the popular language, but it has its own dedicated implementation over here. Okay, now while working with PyTorch, there are some important concepts that you need to be aware of. So let's look into the major concepts that are involved with this PyTorch library. So when we talk about this PyTorch, one is a tensor. So tensor is an n-dimensional array, and the main advantage over here is this n-dimensional array can be run on the GPU, which means whatever the computation speed that I would get with NumPy, let's say if I could say it as 1x, if I run it on GPU, we have seen that we are going to get 200x, 300x times the faster computation on GPU. And the another best part is variable. So here, this has the capability to fine tune the variables, to define the model parameters as variables, and we can fine tune it as per our requirement. And there's a module which will help us to store the state and the learnable weights, which is composed of various variables. And while working with PyTorch, so this just describes how we can actually work with a PyTorch and PyTorch and NumPy. See, if I perform the dot product between the two arrays, so in this scenario, NumPy is going to take 350 milliseconds and the PyTorch is taking 0.1 milliseconds. So imagine the speed of computing that we are getting right now. So that is one of the major reason that we want to make use of these deep learning frameworks when we are performing the complex task of deep learning. When we are training such deep learning neural networks, which will have millions of parameters, you cannot just simply sit in front of system for 3 or 4 days just to complete one epoch. So you want to reach the output faster. So that's where you'll make use of GPUs and the softwares which support GPU computing. So one such software is PyTorch. And here, so the best part is it is very easy for us to convert the data between NumPy array and the PyTorch. So we've got torch.tensor to create a PyTorch tensor, and we've got NumPy array. So NumPy array, and it will share the underlying memory location. Okay, so that's the overall idea about the NumPy array. So they are like, I would say it's very convenient if you're aware of NumPy library. So you can also make use of various functions that we have got in the NumPy library. Like similar functions are made available in the PyTorch as well, so that the developers can actually work. And along with that, this PyTorch has a Autograd module. Now, when I say Autograd module, so this will help us to perform the operation and perform the forward pass and compute the gradients using the backward propagation, and post that we can update the parameters. So we can implement this training loop in an easier manner using this Autograd loop. Okay, Autograd is nothing but automatic gradient or the automatic differentiation. So by doing like this, we don't have to worry about how to calculate the gradient. So we can leave all those complex stuff to the computer, and we can only focus on what we do best, that is describing how our network will be. So that's the overall idea about this Autograd module. Okay, so generally when we are creating a tensor, we'll say torch.tensor. This is a central class of package, and we can say that requires grad as true. So by setting like this, this is going to track all the operation. Now inside this, we will generally perform the forward pass. Then we will say call.backward. So this will help us to start performing the backward pass, that is the computation of gradients. Now, once we compute the gradients, we can then go ahead and start using those gradients into our future activity. And finally, we can stop the tracking history as well. So by calling it as call.detach or torch.nograd. So in this way, the overall flow would happen whenever we are implementing the neural network with the help of PyTorch library. Now, while working, if I want to create a neural network, how do I create it with the help of PyTorch? So let's have a look into that as well. See, if I want to create a neural network, first we'll start by neural network constructs, and we'll create a class by subclassing, by referring the parent class as torch.nn package, and then we'll make use of Autograd by defining the model and then differentiate them. And we'll make use of NN.module. Using that, we'll be defining our methods and the layers. We'll perform the forward pass. And once I perform the forward pass, it's going to generate the output. And then we'll go ahead and implement the backward pass. So this is an example where I'm saying that once I define my model, I'll send the data, I'll find the value of loss. I'll say that 0 grad, that means this is going to set the gradients to be equal to 0. Post that, I'll call loss.backward. This is going to compute the backward pass, and then we'll calculate the gradients and update the parameters with the simple function that's called as optimizer.step. Okay, so this is how we are going to create a training algorithm. Inputs, calculating the loss, back propagation, and updating the parameters. So in this example, the train batch, labels batch, and the output batch, these are the variables that we'll be working, and these derivatives are calculated automatically, and that's the beauty of automatic differentiation functionality. Okay, now when we want to create a neural network, we'll first define a neural network. Okay, the training procedure will include the iterating over the data set, process the input, compute the forward pass, that is the loss, and then propagate the gradients, and then updating the weights. So this is how we are going to create a neural network. So here, when it comes to working, so we'll make use of torch.tensor package with torch.tensor function to create a multidimensional array. And this supports the autograd operations like backward, but there we'll have to define it as variance. Okay, we'll have to say autograd is equal to like gradient, allow grade, like track has to, I'll show you. Okay, we only then we'll be able to track those gradients. So we'll make use of NN.module for the various layers, NN.parameter. So for the parameter, and autograd function, which will implement the forward and backward pass. So this is about how we can create a neural network. Now that you have an understanding, let's go ahead and implement this with the help of PyTorch itself in a hands-on manner. So in order to do this, I'll bring back my Google Colab. So we'll get started with this hands-on activity. This is the notebook that I'm going to use right now. I'll share the notebook over here in the chat window. Please refer the same. Okay, see, this clearly describes the basics of PyTorch, guys. Okay, so if I want to create a PyTorch data, so see, I'm importing torch as well as NumPy library. So if I want to create a tensor, I can just send the data inside my torch.tensor. So if I execute this, you'll be able to see that a tensor has been created. And once it has been created, if I call the type function, it says that this belongs to the type of tensor, that is the PyTorch tensor. And we can also convert the data from array to type torch, that is torch tensor, as well as PyTorch to the NumPy array. So as I mentioned, both are easily convertible. So that describes over here, and that is explained with this example. See, I've created a PyTorch from the NumPy array. And just like we have got random functions, ones function and zeros function in NumPy library, we also have the similar functions in torch library as well. So torch.rand, which will help us to generate the tensor with the required shape, torch.ones to help me to generate the tensor filled with ones, zeros, which will help me to create the tensor filled with zeros. Okay, that's how we create the tensor. Then we have got the shape of the tensor. Okay, and we can also see where exactly the data is stored. We can also save it in the GPU if you would require. So here I am saying that device is equal to CUDA. So in this way, I can actually save the data in the CUDA enabled device, that is the GPU. And I can create the tensor, and I can also perform the mathematical operation. So here I'm specifically saying create in CPU, create in GPU. And while working, so if I want to create a network, so I'm going to subclass my torch.nn.module. Here, we are going to create two methods. One is init method and the forward method. These are the two methods which we have to override from the parent class. So in this init method, we'll define our layer structure. In the forward method, we will specify how does the forward pass should happen. I'm defining it as flatten layer, sequential layer. In the forward method, I'm performing the flattening activity, applying the ReLU layer on the previous output, and finally returning the overall output. In order to create a network, it's like creation of object for this network. Then I can just print it and I can create a network in this way. So that's how easy it is to work with this PyTorch library. All right, team. So this is about the basics of PyTorch and how to work with the various modules of PyTorch and create a neural network in a quick and an effective manner. Okay, so thank you so much guys for joining in. I wish you all the best. So take care everyone. Bye.